Hello and good evening, everyone. I'm your host, Manpreet. Welcome to the sixth season of IST Practicals by Internshala Trainings. IST Practicals is a series of free online masterclasses delivered by industry experts. These 45-minute sessions are all about teaching students important concepts, softwares, and tools. Every IST Practical is an opportunity to experience the power of practical learning. In today's episode, we have Rakesh taking a session on FEA and structural analysis using Ansys Workbench. He holds a master's in machine design with over 7 years of experience as a senior CAE engineer and has taught more than 10,000 students both online and offline. I hope you will enjoy this webinar with him. We have a very special gift for you at the end, so stay tuned for that. तो चलिए करते हैं एंसिस सीखने की शुरुआत यहीं से एंड लेट्स वेलकम राकेश.
Yeah, so thank you, Manpreet, and I welcome you all onto this webinar regarding fundamentals of FEA and structural analysis using Ansys Workbench. Okay, now, so what are we going to learn today, or what is our agenda for today? So, first we'll see what is an engineering problem. Then we'll try to understand what are the different ways that are there to solve any engineering problem. Then, once we cover that, we'll be having a brief introduction about what is the technique of finite element method or finite element analysis. And once we complete that, we'll be having an interface demo of Ansys Workbench software, which is one of the most popular finite element analysis software. Then once we complete that, we'll be having a demo of a small project which we are going to perform using Ansys Workbench software. And once we are done with this, we'll also try to talk about some of the opportunities that are available once you learn Ansys Workbench software. Okay, so before going forward, first of all, what do you define as an engineering problem? So once we know the definition of what engineering problem means, then we can look at what are the different ways in which we can solve an engineering problem. So how can we define an engineering problem? So any problem, or let us say any problematic situation that can be solved using engineering sciences and methods, that can be defined as an engineering problem. Suppose, for example, if you want to design a bridge through which vehicles have to pass through. So you will try to use the engineering methods, and then you will try to solve the problem, and you will try to create the design. So this is one example of an engineering problem. Okay. Then before going further, okay, we have seen what an engineering problem means. Now, can you people give me one or two examples of the engineering problems that you come across in your daily life? Because there will be number of problems which you can get examples for. You can just type in your chat window. So can you people give me some examples of engineering problems that you come across in your daily life? You can just simply chat in. You can just type in the chat. So I'm getting responses like design of turbine. Yeah, it is one of the engineering problem. But I want generalized engineering problems, not advanced engineering problems. I want some examples of the problems you come across in your life. So technical problems in machines. Okay. Design of belts, V belts. Design of V belts. Yeah. Design of shafts. Motion of a car. Yes. So these are whatever the things that you are saying. These are some of the examples of the engineering problems which you come across in your daily life. To be much more simple, suppose for example, let us say you are seeing a car, as one of the person stated. Your car is going to run. So how it is going to run? So for in order to run the car smoothly, we have to solve number of engineering problems. So that is one of the best example. Likewise, motorcycles, Even your design of watch is one of the engineering problem. Design of laptops, electronics and other stuff, these all come under engineering problems. Okay, now let us continue with the presentation. So, once we come to know what is an engineering problem, then we'll try to understand what are all the different ways that are there in order for us to solve an engineering problem. So, in order to understand the methods that are present, what we are going to do is we are going to take an example. So, here we are taking an example of a person. So, he wants to cross this particular river, stream, or whatever the thing, or canal, something, on this wooden plank. Now he's getting a question: shall I cross or not? If I want to cross, will this wooden plank be able to bear my weight? Okay, he has this particular problem. Now, one way to know whether it can bear the weight or not is to perform something called as experimentation. So in experimentation, what he will do, he will try to get onto this particular wooden plank and he will try to pass. So if it is going to bear his weight, it will not break. If it is not able to bear his weight, this particular wooden plank or wooden beam, whatever it is called as, it will break and he is going to get drowned. He is going to get drowned. So this particular way or this particular method or this particular approach is what is called as experimental approach. So in experimental approach, what we are going to do, we are going to try to create the entire problem and we are going to test it physically, and then we are going to see whether our problem can be solved with the method or the way we have selected or not. So this is one approach. This is what is called as an experimental approach. Now, coming to the second approach. Okay, in the second approach, what I do is I have a lot of creativity. I know a lot of mathematics and I can simplify complex systems. So what I will do is I will try to simplify this wooden plank and this entire wooden plank into the system, something like this. So we have two supports and this is the force, or let us say this is the weight of this particular person. So I have simplified this system into such kind of a system, and using mathematics, differential equations, or let us say theory of elasticity, theory of plasticity, what I will do is I will try to derive some formulations, or I will try to derive some formulas just like this: deformation equal to PL cube by 48 EI, something like that. And once I derive this particular formulas, I will try to understand whether this wooden plank is going to bear my weight or not. Okay, this way of approach is called as analytical approach. Analytical approach. But there is one main problem with analytical approach. So whatever the systems we can think of, or whatever the systems which we can consider here, all those systems should be simple enough. All those systems should be simple enough. If we try to apply this analytical method to a complex problem, or let us say very high end problem, it might not be possible. It might not be possible. So you can remember one thing: analytical approach is applicable for simple problems. Okay, so this is another way. Then what is the third way? So third way is we will again simplify this system somewhat like this as supports and force, but here instead of using very complicated equations and other stuff, what we are going to do is we are going to make use of linear algebra, and we are going to derive some matrices like stiffness matrix, deformation matrix, and force matrices, and then we'll try to solve the system of linear equations through which we'll try to understand whether this particular wooden plank is going to bear our weight or not. So this approach is called as numerical approach. So whatever the technique of finite element method or CFD, you people might have heard of CFD, or you might have heard of FDM. All these methods come under what are known as numerical approaches. Numerical approaches. Remember, the main difference between analytical approach and the numerical approach is in numerical approach we can apply this numerical approach to any complicated system, but analytical method, it is very difficult to apply for complicated systems. And if you are going to perform analytical solution, you will be getting accurate results, but when you try to solve any problem using numerical approach, you will be getting an approximate result. So these two are the main differences between numerical approach and analytical approach. Then if you don't want to do any of these things, then there is another final approach. That is nothing but you will go to some local who always or who daily crosses that wooden plank, and you will ask how much weight it can bear. And if he is able to help you out, he will be helping you out that okay, this wooden plank will be able to bear your weight and you can cross safely. So based on his word, you can go. This is learning from past experience of others. So these are some of the different ways in which we can solve any engineering problem, guys. Any engineering problem. Okay. Now, so before going further, I want to know how many of you people have heard of the term finite element method, or let us say FEM. And if you have heard of FEM, then can you just give me the full form of FEM? Just type in the chat. You can just type in the chat. What is the full form of FEM? Yeah, as I already mentioned, it is finite element method. Yeah. So can I ask you one question, like how many of you people are currently studying fourth year? Can you just type in the chat? Fourth year. Okay. Okay, we'll continue with this one. Yeah, finite FEM is nothing but finite element method, and another term for this same is FEA, which is nothing but finite element analysis. So FEA is nothing but using finite element method to solve problems that can be defined as finite element analysis, FEA. Okay. Now, so first of all, we'll try to understand what finite element method or finite element analysis is. So we have a very complicated system, something like this. So we'll take this complicated system and we will divide this complicated system into number of small parts, so that what will happen, these small parts we can easily solve for the required answer. Suppose for example, if I want to find out the deflection in this particular object, so what I will do, I will instead of solving for the deflection on the entire object, I will divide this particular object into number of small pieces. So the process of division of a complicated object into small objects, this can be superficially defined as meshing. Okay, this can be superficially defined as meshing. Okay. And once we are done with meshing, that means dividing this complex object into small solvable objects, we will be solving all the required problems. And once we are able to solve all the required problems, then what we'll do is we'll combine all the solutions into a single solution, and we'll be able to find out the solution for the entire system. So what we are going to do here, we are going to convert a complex system, this is a complex system, into number of simplified systems. And once we have done that, we are going to solve and find a solution for our problem. For solution 1, for this it is solution 2. Likewise, for every simplified system we are going to find out multiple solutions, then we'll combine all the solutions to get a cumulative solution for the entire complex system. This is the cumulative solution for the entire system. This is the basic process which is going to be undertaken in the method of finite element analysis, or using the technique of finite element method. Okay. Now, see, in terms of mathematics, we have a physical phenomena. So here we have some physical phenomena. What we are going to do, we are going to convert this physical phenomena into some governing equations, and we are going to again convert this governing equations into system of linear equations, and we will solve these equations in order for us to find out the required solution. Suppose for example we have a cantilever beam like this, and I have applied some load here, and I want to find out the deflection. So what I will do is I will convert this entire system into different stiffness matrix, deformation matrix, and force matrix. Then I will solve the system of linear equations, and once I solve the system of linear equations, I will be getting the required deflections, stresses, strains, and whatever the other quantities I require. So this is basically what is finite element method. Okay, I hope you understood about finite element method in a superficial way. Okay, now, so why are we supposed to study FEM? Why are we supposed to study FEM, or let us say in general, why we are supposed to go for numerical methods? One thing, as I already mentioned, analytical approach can be applied for only simple problems. Okay, but for complicated problems, if we want to solve them, we have to go for numerical methods. In that numerical methods also, suppose for example, let us say we have taken this particular example. So in this, what is happening, if we want to go for experimentation, it is a very costly affair, as well as see here, human, we have to involve a human, which is ethically not at all correct, so if you take a human and subject him to an crash or an accident, is it ethically, like, is it acceptable? No, I don't think so. So in order for us to overcome that ethical problems, as well as cost problems, one way or one approach is we can go for finite element method, and we can use different softwares. We can use different softwares such as Ansys, or Abacus, or Hypermesh, or Hyperworks, to simulate the same things in a computer, and we'll try to understand what is going to happen if that particular scenario is going to come or occur. Okay, this is one way. One is to save cost, second one is ethical concerns, and next one also, if you want to understand in depth, what is happening in the entire system, computer simulations or studying a physical phenomena using finite element method is going to help us a lot. For example, if you are able to see here, you can see what are all the localized stresses that are occurring inside this particular struct member. So if you are not going to use the finite element method, if you directly conduct experiments, what will happen, we have to conduct number of experiments until our design is going to be, what do you say, design, or correct design is achieved. That is one thing. Then one more thing is, we cannot study at this granular level using experiments. Even though if we want to study all these granular things at experimental approach, it is again very very time consuming, as well as costly. So what happens is, industry people first, they will create ideas, and they will test out all those ideas using the finite element software, and once they finalize what idea is going to work for them, then what they will do, then they will do experiments, one or two experiments, and they will finalize that whatever the things that we have decided are correct or wrong, or do we need any change to the design. So this is basically it. Then coming to CAE, you might have heard of the term CAE. Okay, until now we have seen finite element method, or let us say finite element approach, but you might have heard about a CAE software, or computer aided engineering software. So it is nothing but when we are trying to use computers and computer software to resolve engineering problems, it can be easily, or it can be simply called as computer aided engineering. So if you are trying to simulate any system, or if you are trying to optimize any system, or let us say if you are trying to validate, you have an idea and you are trying to validate that idea is going to work or not using computers, that itself simply can be called as a computer aided engineering software. Computer aided engineering software. Okay. Now, here is a quick poll. So, I think you people, if you are studying engineering, what will happen is you might have come across a number of softwares. It may be CAD softwares, it may be CAE softwares, it may be some programming languages and other stuff. So, can you just type in the chat what are all the different softwares that you have heard of or you have used as a part of your curriculum or as a part of your daily life? So, can you just type in? So I'm getting mostly AutoCAD. Yeah, obviously engineering students mostly in their first year or second year will be going towards AutoCAD. And fine, KTR, SolidWorks, Ansys. Yeah, I have seen few people going with Hypermesh, Abacus as well. Oh, Abacus, it's good. So AutoCAD, StatPro, yeah, SolidWorks. So anyway, I have seen like people typing in MATLAB. So I have a question. If I go back, see here, according to this definition, any software which we use for resolving engineering problems that can be easily qualified as computer aided engineering software, right? So is MATLAB a CAE software? Can anyone like answer this question? Is MATLAB a CAE software? Yeah, I'm seeing few people Fusion 360, Python. Yeah, guys. One thing is in general, even MATLAB, even if you are using Python for solving any engineering problems, technically, it can be called as a computer aided engineering software. Computer aided engineering software. There is a difference between CAE software and FEA software. So CAE software is a software which you will be using for solving engineering problems in whatever the method might be. It may be using equations or it may be using different graphical user interfaces and other stuff. But finite element softwares are different. Suppose, for example, number of people, as they mentioned, ANSYS is a finite element software, and mostly in general what happens is because people think like CAE means simulation and other stuff, so they tend to take this Ansys, Hyperworks, Abacus and all these softwares as a CAE softwares. Okay, so that's fine. Yeah, mostly. Yeah, some people are typing in Python as a object oriented programming language. Okay, that is fine. But if we are going to use it for solving engineering problems, because I myself used Python for solving number of problems, so that can be technically, it's not like perfect, but it can technically be called as CAE software. Okay, then. So, what are some of the applications, or let us say application fields of CAE software? So we already know that in any software where there is a product design involved or product testing is involved or material design, material testing, all these kinds of things, we'll be having the application of CAE softwares. The application of CAE softwares. For example, automotive. Automotive is one area. Aerospace and defense, marine, electronics, structural engineering, sports, and lot of other things. So these are some of the most popular areas. So that is why I mentioned only these areas. But see, guys, wherever there is a creation of product or we are creating something new, there we can find the applications of CAE, especially in defense. See, defense, automotive, aerospace, and other stuff. Okay, now. So we have one more quick poll before we continue further. So how many of you people have heard of ANSYS before? So can you just type in your chat? So how many of you people have heard of ANSYS? Like even if you have heard of ANSYS, how many of you people have heard of ANSYS APDL and how many of you people have heard of ANSYS Workbench? Yeah, number of people, yes, they have heard of it. Okay, fine. So even if you have heard of Ansys, did you hear about Ansys APDL or Ansys Workbench? Okay, so few people already have did their major projects on it. That's nice. Yeah, few people have heard of Ansys Workbench as well. Yeah, yeah, I'm seeing few people they used Ansys and they published a few papers. Congratulations. Yeah, yeah, okay, fine. So here in this particular presentation, we are going to talk about Ansys Workbench. We are going to talk about Ansys Workbench. So we are not going to go for Ansys APDL because mostly in the industry we'll be using Ansys Workbench because we'll be dealing with more complicated problems. But it is not like that we are not going to use APDL. But here our main focus is going to be on Ansys Workbench. Okay. So basically, to state, Ansys Workbench is a simulation or let us say finite element project management tool. Can be considered as a project management tool, or it can also be considered as a top level interface that links different software tools that are developed by Ansys. So before going to the Ansys demo, inside Ansys, we'll be having different modules for performing different types of operations. For example, if I want to create geometry, or let us say I want to import geometry, I have a module what is known as a design modeler. Likewise, if I want to do meshing, or let us say if I want to do apply loads and boundary conditions, for that I have what is known as Ansys mechanical. Likewise, if I want to create materials and other stuff, I have a module called as engineering data manager. So Ansys Workbench on a top level, it can be considered as an interface which links all these modules together, and also using Ansys Workbench, we can transfer data from different modules. So if you don't get what is Ansys Workbench now, you don't need to worry. Anyway, we are going to have a demo of this, so you don't need to worry about that. Okay. Okay. So before going that, what I'll do is I will open the Ansys Workbench. So it may take 1 or 2 seconds based on your system configuration. So you don't need to worry much. Yeah. Yeah, fine. So once the Ansys Workbench is open, this is an overall interface of Ansys Workbench, and I hope you all people are able to see. You are able to see this properly, right? Hello. Yeah, you can just type in. You can just type in the comments. Are you able to see it or not? Okay, fine. Now, so whenever you open Ansys Workbench, you will be greeted with somewhat a similar interface. In this interface, you will have an area called as toolbox, which is one of the important area. Likewise, you will have an area called as a project schematic. So on this project schematic, what we are going to do, we are going to place different analysis systems and different component systems, and we are going to do our project. We are going to do our simulation project. And if we come to this toolbox area, here also there are 5 different groups here, in which you will be mostly using analysis systems group, and you will be using component systems group. Okay. So before describing what analysis system is and what component system is, we have to know what are all the different steps that are involved in solving an engineering problem using finite element method. So whenever you take a problem, first thing is you are going to create the geometry. And once you create the geometry, the next step is you will be defining the materials, and then you are going to perform meshing on that particular object. And once you perform meshing, then you will be applying the loads and you will be applying the boundary conditions. And once you have applied all these things, you will be solving the problem. And once you solve this particular problem, you will be able to find out the required solutions. Basically, these are the series of steps. So in order for us to perform series of steps, what will happen is our Ansys Workbench will provide us with few templates. It will provide us with few templates. Suppose, for example, let us say I want to perform what is known as a structural analysis, that too static structural analysis. So I need to come to this toolbox area, and in the toolbox area, I will just expand this analysis systems group. See here, I will be expanding this analysis systems group, and then if I am going to drag and drop the static structural analysis system onto the project schematic, see here we have different cells. These are what are known as cells, guys. Okay, so these are known as cells. So we have different cells, and if you click on different cells, you will be able to perform different kind of an operation. For example, if you are going to double click on the geometry cell, you will be able to create geometry, or you will be able to import the geometry that is required for our analysis. Likewise, if you are going to double click on the engineering data cell, what will happen? You will be able to you will be able to define an material which you are going to use for our analysis. Okay, now, likewise, if I double click on the model cell, I can perform meshing and other stuff, likewise setup and other things. Okay, now, once we have known a very basic introduction of the ANSYS interface, what we are going to see is, guys, one more thing is, if you are able to see, few cells are highlighted in blue color and other cells are mostly highlighted in white color. That means any cell which is having a white background, we can double click on that particular cell to open a specific module, but whatever the cells that are highlighted in blue color, they are just a static cells. So static cells means what will happen? We can't edit that particular cell. Okay. Likewise, if you come to these component systems, whatever the systems that are present here in the cells, they are individually present in the component systems. They are individually present in the component systems. Suppose, for example, if I come here, if I click on the geometry cell, what will happen? It is going to open a module called as design modeler. Likewise, if I don't want to use it as a part of an analysis system, what I will do, I will drag and drop the component system individually. Now, one more thing, guys. See, you are having some denotions like A, B, C, and like that. Okay, it is being denoted like that. Okay, so now if you want to identify, let us say, a static structural setup cell, how you are going to define it? You are going to define it as A, and the number of the cell is 5. So if you are going to say A5, that means what I need to understand, I need to go to the A analysis system, and in the A analysis system I need to go to the setup cell. For example, if I am going to, let us say, drag and drop this model analysis system, and let us say if I tell you to go to C3, that means you need to come to the C system, and in the C system you have to come to this geometry cell. And basically, whatever this status of this cell is there, it is being denoted by different symbols here. If you are able to see, there is a tick mark, there is a question mark with the filled blue color, there is a question mark here also question mark. So different cell states are denoted by different symbols. Okay, so we are going to see, anyway, don't worry, we are going to see what are different cell states and other stuff. So for now, what we are going to do is we'll switch to the PPT, and we'll go for this. Yeah, we'll yeah. So we'll go for this particular demo, and once we finish this particular demo, we'll be having a quick quiz. Okay, fine. So here we are having a problem, like we are having a stepped shaft. So the diameter here is 60 mm, and the diameter at this is 30 okay, and the length of this side is let us say 100 and this side is 100 okay. Now we have a radius, a fillet radius of 8 here. Then we are applying an axial load of 14 kilonewtons. We are applying axial load of 14 kilonewtons. So now what is my main aim? My main aim is to find out what is the maximum stress that is generated inside this particular stepper shaft. That is the first thing. And the second thing is I also want to find out the stress concentration factor, because if you observe guys, the cross section on this side and the cross section on this side is different. That means it is changing. So we'll be having a stress concentration factor somewhere here in this particular region. So what we are going to do is we are going to perform some hand calculations on the same problem. Likewise, we'll also perform some calculations using Ansys Workbench, and we'll try to compare. We'll try to compare both the results as well. Okay. So I hope you have understood about this particular problem statement. Now what I will do is I will switch back to Ansys. I will switch back to Ansys. Now, once I switch back to Ansys, what I'll do is I will go for new. I don't want this particular project. I am creating a entirely new project. And once I've created the new project, the first thing I'm going to do is I'm going to go to the units, and in the units drop down menu, I will select different units. So I can select different predefined units, or let us say if I click on the unit systems here, I can even create my own custom units as per my requirement. See, by default, there are around 17 unit systems that are already predefined inside Ansys Workbench, and you can directly make use of them directly, or otherwise you can even create different custom unit systems. Okay. For now, what I'll do is I'll just close the unit system manager, and now I will go to the units, and here the units is set to metric kg meter. Okay, I'm fine with this unit system, so I'm going to leave it alone. And once I'm done with this, the next thing is, see here, I want to perform what is known as a static structural analysis. See, simply to define static structural analysis, let us say you want to find stress, strain and deformation on any object, you can perform static structural analysis. So it is one of the easiest analysis to perform and one of the basic analysis that we are going to perform. Okay. Now, in order for us to perform static structural analysis, I'm going to drag and drop the static structural analysis system onto the project schematic. And once I dropped it, see guys, as I told you, first we can either import the geometry and then change the material, or otherwise, as denoted by this particular template, we can provide the material. We can provide the material first and then take in the geometry. But before going that, you also need to remember, you consider any of the CAE software, any softwares which uses FEM, like suppose Abacus. A few people have told me Abacus, and a number of people have told me Ansys. Likewise, Abacus and Hyperworks. So whatever the software you are going to take, whatever the steps that we are going to see here, whatever the steps we are going to see here, that are going to remain same, there will be no difference. The only minor difference might be in few softwares we'll be defining the geometry first, in few softwares we'll be defining the material first. Other than that, there is and interface difference anyway, usually interface difference will be there, so don't worry about that. But the process, whatever the process we are going to follow, it is going to remain same. So now, in order for me to define engineer like a material that is required for our analysis, I'm going to double click on the engineering data. And once I double click on the engineering data, see here, whatever the module is open, this module is known as engineering data manager. Engineering data manager. In this, we have toolbox component and four different windows. So this is the first window. So this is called as outline of schematic window, in which whatever the materials that we have defined for our analysis, all those things, all those materials will be present here. Likewise, whatever the material properties that we have defined for the existing materials, all those properties will be shown in this particular window, which is nothing but called as a properties of outline. Likewise, if we define any tabular properties, that particular table will be defined or will be shown in the table of properties row. Likewise, if we have defined any tabular data, that will be shown in the form of a graph. Suppose, for example, for this structural steel, I have defined SN curve. And once I click on SN curve, see, whatever the tabular data of properties that we have defined here, it is shown, and the same tabular data, it is being represented as a graph in the chart of properties, okay. Likewise, if you want to create materials, you can create materials or you can add materials in two different ways. The first way is you can use the materials that are already predefined inside Ansys Workbench. That is one way. Or second way is you can define your own material. Suppose, for example, if I click on the engineering data sources, see here, I am able to access one more window which is called as engineering data sources. You can just drag these windows like this, so that you can increase the size of the windows, okay. Now, so if you see, we have up to like 13 12 to 13 predefined libraries, material libraries, that is already present inside Ansys Workbench. So if I click on any of the material library, whatever the materials that are present in that particular library will be shown in this particular window. Okay, so from here I can click on this plus symbol to add any material to my analysis, or otherwise what I will do is I will just turn off the engineering data sources, and I can just type in here steel, and I can define whatever the properties that I require. So for example, let us say if you are considering isotropic materials means, mathematically, if you want to define isotropic materials, what are the main properties you need to be providing? You need to be providing the Young's modulus value, likewise Poisson's ratio value, and if you want to test out failure, you will be giving the tensile strength, as well as compressional strength and other failure criteria as well. Suppose you want to perform thermal analysis, you will be providing with the thermal properties. So in order to define a custom material, what are all the properties that are required? You can find all those properties in this toolbox group, in the toolbox area. Suppose, for example, let us say I want to define the density of this material. I can go to this physical properties, and in the physical properties group, I can just drag and drop the density value here, and here I can select the units from different available units, and then okay, sorry. Okay, and then you can provide, you can just enter the value, okay. So this is how it is done. For our present problem, structural steel is the material that we are going to take, so we don't need to define any other material, okay, any other material. So I'm going to delete this custom material. And you also need to remember one thing is that by default, once you open Ansys Workbench, structural steel is the default material that is always defined. That means if you are not going to define any material, by default structural steel will be applied for your analysis. So it is going to be considered as the default material for your analysis. Okay, you need to remember this point. And now once we are done with the defining materials, I will close this engineering data tab. And now the next thing is geometry. So I'm going to double click on the geometry cell, so that I will open a module called as design modeler. And you need to remember one thing is that there are two different geometry modelers inside Ansys Workbench. What are those two? One is the design modeler, next one is the uh, space claim. Next one is the space claim. So for most of the advanced modeling operations and advanced editing operations, we will go for space claim. But if you are strictly performing finite element analysis, in most of the cases, which I came across, I mostly use design modeler only. I mostly use design modeler, and a number of people also prefer to use design modeler. Why? Because it is somewhat simpler to use when compared to the space claim. Okay, but if you want, you can also even use the space claim. Okay, now instead of creating the geometry here, what we are going to do, we are going to import the required geometry. Even in industry also, if you see the CAD engineer, or let us say the product design engineer, he will be creating the concept using CAD software, and once he saved the CAD files, he will be sending those CAD files to us. As a CA engineer, what we are going to do is, we are going to upload them into our Ansys software, or we are going to import them into our Ansys software, and we are going to perform our analysis. We are going to perform our required analysis. So for that, what I'll do is, I will go for the file. But before importing, what I'll do is, here if you check, the units are in meters. So I will come here to the units option, and I'm going to change it to millimeter. I'm going to change it to millimeter. Remember guys, this all depends on your usage. You can select whatever units you want. It depends on your usage. Okay, now once I've changed the unit system, I will go for the file, and I'm going to click on import external geometry file. And once I click on import external geometry file, I will go on to the desktop where my file is stored, and I'm going to open it. And once I click on open, now I need to come up to this tree outline. And in the tree outline, I need to right click and say generate, and if you are able to see, we have imported this particular geometry, solid geometry. Okay, why it is showing transparent? Like a transparent means, you can go for view, and you can also click on frozen body transparency to off. So what will happen is, it will be displayed as a solid object. And once we are done with the geometry step, then what is the next step we are going to do? As I already mentioned, one thing is geometry creation or geometry importing, then defining geometry. The next thing is, we have to perform meshing on this particular object. So in order for us to perform meshing on this object, we need to double click on the model cell. And once we double click on the model cell, we are going to open a module called as Ansys Mechanical. Remember, Ansys Mechanical is one of the most important module. It is one of the most important module throughout entire Ansys Workbench software. Why? Because it is the module in which we'll be able to perform different kinds of analysis, structural analysis, thermal analysis, and other lots of kinds of analysis. Okay, now, so it may, like, if you are opening Ansys Mechanical for the first time, or let us say if your system configuration is not that good, it might take time. You don't need to worry. Okay, so once our required Ansys Mechanical is open, the next thing is, I am going to what is known as an outline tree. So this outline tree will have all the different options that are useful for applying meshes, or let us say creating meshing on this object, applying loads and boundary conditions, and even finding out different results. Okay, now, so in order for me to perform meshing, what I'll do is, I will come here, and I can right click on the mesh branch, and I can say generate mesh. So if I click on generate mesh, what will happen is, with whatever the default settings are there, all those with all those default settings, our mesh will be generated on this object. Okay, but what I'll do is, I will right click, say insert, and I will go for the sizing, and I will select this face as well as this face, and I'm going to click apply, and I'm going to give the element size to be 5. For now, you don't need to worry about, like, how did I select this meshing size and other stuff. For now, we'll just look at, like, what are the steps involved in solving a FEA problem. Okay, now once I have given the meshing, what I'll do is, I will right click and say generate mesh, and right click and say generate mesh, and we have generated a mesh. We have generated one rough mesh. Okay, for now it is enough. For our purpose. Okay, once we have performed the meshing, the next thing is, we need to apply loads, and we need to apply boundary conditions. We need to apply boundary conditions. Okay, but before applying this loads and boundary conditions, what we are going to do is we'll be going back towards our PPT once. Okay, we'll be going towards PPT now. So here, what is the, if you consider guys, what is the force that we are going to apply? It is nothing but 14 kilonewtons. Yeah, 14 kilonewtons, right? And we have this different diameters, height, diameter, radius, and f. Okay, now before going that, we'll have a small quiz. Before continuing with that, we'll be having a quick quiz. Okay, so can you tell me, like, can you people answer, like, what is the default material that is always predefined inside Ansys Workbench? Yeah, yeah. So remember, whenever you don't define any material, always you need to consider that the material is structural steel. Okay. Now, a number of people are saying correct answer only. So it is nothing but structural steel. Okay. It is nothing but structural steel. Okay. Then we'll continue with the problem. We'll be continuing with our problem. Okay. Now, we know that we are applying a load of 14 kilonewtons. 14 kilonewtons. Okay, fine. So now what we are supposed to do is we are supposed to manually find out. We are supposed to manually find. Just a second, guys. We are supposed to manually find the area. So what is the area on which, what is the area on which we have to apply this 14 kilonewtons? So based on that, we need to find out the area. So can you guys guess what is the area on which we are going to apply the 14 kilonewtons? One thing is I'm going to apply a fixed support here. I'm going to apply a fixed support here. And this is the area. This is the area on which we are going to apply 14 kilonewtons. I only have revealed that. But can you guys calculate what is the area of this particular cross section of the shaft? So can you calculate and give me an answer? What is the cross section area? What is the cross sectional area? Can you guys give me the answer? Like, what is the cross area of a cross section? So it is nothing but it's 706.85. So how did we get it? It is nothing but using the simple formula. What is that formula? Pi by 4 d square. Pi by 4 d square. And if you go to this one, see, pi by 4 d square means the diameter of this cross section is 30. So pi by 4 into 30 square will be getting somewhere around 706 something mm square area. Okay, that is fine. Now, next thing is you will be finding out the d by d ratio, that is the larger diameter by smaller diameter ratio, which is nothing but 2. And you will also try to find out the radius by diameter ratio, which is nothing but 0.22. Manpreet, can you just give that document in the, you can post the document in the chat so that people can download and see. Yeah. So using this d by d ratio and r by d ratio, what we are trying to find is we found out theoretically our whatever the stress concentration factor is there, it should be somewhere around 1.4 or little bit less. 1.4 or little bit less. How did we find out? See here, for d by d ratio of 2, this is the curve. So This is the curve for the d by d ratio of 2. And what is the r by d ratio? It is somewhere around 0.266. So somewhere around here. So if we plot a line like this, so whatever the line that is going, whatever the value that we are having here, somewhat here, it is nothing but the our k value, kt value, which is nothing but 1.4. So theoretically our kt or stress concentration factor should be 1.44. And in addition to this, also try to calculate we'll also try to calculate the nominal stress. So you people have you might have studied that the nominal stress, force by area. So it will be giving me somewhere around 19.8 newton per mm square, newton per mm square. What is the force? It is nothing but 14 kilonewtons. Area we already know, pi by 4 d square. Okay, so from that we'll be able to we have like we deduced this nominal stress, which is nothing but the 19.8 newtons per mm square. And if you remember the theory, this stress concentration factor kt equal to sigma maximum, that is the stress maximum by sigma nominal. And using this formula, if we are going to deduce sigma max, it is nothing but sigma nominal into kt. And what is the value of this? Can you people tell me the value of this? Can you people deduce the value of this? So what is the maximum stress that is induced inside the object due to the stress concentration factor and other stuffs? Can you tell me? You can comment your answers. You people can just type in, like you can just comment in the chat box. So the answer is C, and number of people, yes, yes, yes. Yeah, fine. So, yeah, this is the same C, 27.72 MPa, 27.72 MPa. So now what we are supposed to do, whatever the problem that we are going to solve inside Ansys Workbench, we need to get a maximum stress around 27 to 28. Likewise, whatever the stress concentration factor that we are going to deduce, that is should be around 1.4. I think this is clear with you. So once I am done with this, I have switched to Ansys Workbench. Now what I'll do is I will just right click on the static structural, and I will go for insert. See here, I'm going to take a fixed support. I'm going to take a fixed support, and I'm going to select this one and this face, and I'm going to click apply. So what do you mean by fixed support? Fixed support means we are going to stop all the types of motions, all motions on this particular face. That means based on this particular phase, this body cannot move. Okay, so this is what is fixed support. Then the next thing is I'm going to right click. So this fixed support is the only boundary condition here, is the only the boundary condition. Then the next thing is I'm going to right click and say insert, and I'm going to click on force. And once I click on force, see here, I'll be selecting this particular phase, and I'm going to click on apply. And once I click apply, if you remember, force is an vector quantity. Vector quantity means it should have both magnitude as well as direction, right? So first of all, I will define my magnitude. So what is the magnitude? It is nothing but 14 kilonewtons, 14 kilonewtons. So I'm going to just type in 14E3. That means 14,000 newtons, or let us say 14 kilonewtons. And once we have defined the magnitude, see here, there is an arrow which is representing the direction of applied force. If you see here, we have an arrow. Okay. Now, if we are satisfied with the direction of that, we are not going to change it. Suppose, for example, if we want to change the direction of the arrow, we can click here on the direction, and we can click on these arrows to either reverse it or keep it like that only, keep it in the first applied direction. So I'm going to click apply here, and once we have applied all the required boundary conditions and loading conditions, the next thing is I'm going to click on solution, and I'm going to click on solve. And once I click on solve, remember, this entire system, based on the mesh that we have created, our software is going to create stiffness matrices, deformation matrices, and force matrices, and using that linear equations, it is going to solve and find out displacement, stresses, and strains. Okay, now once the solution is done, remember guys, how much time it takes for the solution to be done depends on number of factors, depends on mesh, likewise depends on the hardware you are using, depends on the type of analysis you are going to perform, and lot of other factors. Okay, so once our solution is done, the next thing what I'm going to do is I'm going to right click on the solution, and I will go for insert, and I will go for the stresses, and I will click on equivalent von Mises stresses. So what I'm doing here, I'm just requesting the computer to give me what are all the equivalent stresses that are produced inside this particular body, or let us say stepped shaft due to the applied forces and boundary conditions, so once I've requested that result, I need to come right click on this and say retrieve this result. And once I click on retrieve this result, see here, the maximum stress we were able to obtain is somewhere around 26. So it is very much near, it is not exactly matching, but it is very much near to some 27. If you change the mesh, what will happen is you will be able to obtain more accurate stresses, but which we are not going to do in this particular session. But if you want, you can even further, let us say we'll do one small thing, like I will come up to this particular faces, and in addition to the faces, I will select these two faces as well. I will click apply, then we are going to directly click on solve. So once I click on solve, our updated mesh will be created, then the fixed support forces and everything will be applied, and the solution is done. And if you see, our equivalent stresses has changed. See here, it is 26.53, which is very near to 27, which we have calculated manually. Okay, now the next thing is we are supposed to calculate the stress concentration factor. So in order for us to calculate the stress concentration factor, what I'm going to do is, first of all, I'm going to switch to this one. Okay. Now what we'll do is, see, what is the maximum stress we obtained? It is somewhere around 26 point some, let us say 9 or something, which we obtained from the Ansys software. So first of all, we are going to take the force applied, which is nothing but 14 kilonewtons. Then we are going to convert this into some pressure, like 14 kilonewtons divided by area, which is nothing but 706. Okay, 706. Okay, if we are going to divide that, what we are going to obtain, we already know that is nominal stress 19.08. Okay, and what is the formula of kt is nothing but sigma maximum by sigma nominal. Okay, so what is the sigma maximum? Somewhere around 26.9, or let us say 27, and our this one is 19.08, which is equivalent to some 1.32 or something. Okay, which is very near to the uh, estimated value of 1.4, which is very near to the estimated value of 1.4. See guys, we'll have little bit difference, we'll be having little bit difference, and a difference up to 5% is also acceptable. 5% is also acceptable. So if we are going to perform, let us say if we are going to change different meshes and different mesh settings, and we try to get what is known as a mesh convergence, once we perform what is known as a mesh convergence study, then we will be able to identify the final solution. So this is basically it. So these are different steps in which we are going to use to solve any problem inside Ansys Workbench, or let us say any FEA software in general. Okay, I hope you guys had a very brief understanding of how the process takes place. And one more thing is, because by default the material for this object is structural steel, so that is why I didn't apply that material here, because I told you that by default it will be applied. If we are going to give any other material, we might need to come to this materials group, and in the materials group, from here we will select and change the material. We will select and change the material. Okay, so this is basically it. I think I am done with this session. Manpreet, you can take over. But I think before Manpreet, like if you people have any questions, you can even ask me. You can ask me if you are having any questions.
Hi Rakesh, thank you for the amazing session. I think before we go into that bit, I would like to ask you a question first. And this is a question that I think somebody was also asking in the chat earlier. So my question to you is that somebody who is eagerly interested in learning more about this particular domain, what is the right path for me and what are the career opportunities?
Yeah, okay, fine. So if we see, first we'll talk about some of the job opportunities, especially a fresher can get. So one thing is design engineer, because even you being a design engineer, you should be having basics of, you should be knowing how the analysis will be done, and you also need to know how digital validation and other things are done. So for that you need to learn basics of CAE. Then you can directly become what is known as a CAE modeler, wherein what he will be doing is he will be taking in the geometry, he will be doing from some pre-processing tasks and other stuff. Likewise, you can become CAE analyst if you are knowledgeable enough. They might even take you as a CAE analyst, but it is very very rare for a fresher to become a CAE analyst directly. Mostly they will be becoming what are known as CAE modelers, meshing engineers, and validation engineers, and test engineers. So these are some of the opportunities that you can get, especially with learning CAE as a fresher. Okay, and once you are going to get 1 or 2 years of experience, you can even go as a CAE analyst. You can develop as a CAE engineer, CAE senior engineer. Likewise, you can develop then product owner, like that. Okay, now the next thing is, basically this is the most important thing, that what are the different skills that are required for you to become a CA engineer. That's very very simple. A lot of people think that becoming a CA engineer is a very difficult task, but if you have right skills and right tools, it is very very easy. So first thing is, you need to have strong grip on subjects like finite element analysis, engineering mechanics, strength of materials, heat transfer, metallurgy, vibrations. These are absolutely must. You need to be honing your skills regarding the basics in this particular subjects. Okay. And once you have this subject knowledge, remember guys, basic subject knowledge, not too advanced, but up to intermediately level is itself enough. Then you need to be learning any software tool, any CAE tool. See, generally for meshing, most of the companies they use a software, either ANSA or Hypermesh. For analysis, 90, not 90, around 70% of the industries they use Ansys, and rest of the industries they use Abacus, Hyperworks, and other different kinds of CAE softwares. You can directly go and Google it out. Ansys is one of the most widely used analysis software. So you need to be learning any one CAE software. You need to be learning any one of the meshing tools. Okay, and once you are done with the subjects as well as the softwares, the next thing is you have to you have to create some hands-on projects. You have to create some hands-on projects. Like previously some people have mentioned that they have used Ansys software for performing their for completing their major project in engineering. Okay, so that is one way in which you can showcase that subject, the software tool, the software tool. Likewise, if possible, you can work as an research assistant, or let us say any assistant in research projects which are mostly like dedicated towards analysis, as well as CAE. It might not be only Ansys. You can use any software, that is okay, but if it is using Ansys, okay, it is very very good. But if that is not the case also, you can go and work as a research assistant, so that what will happen is you'll be able to understand how the CAE works and what are the things that are going to happen in that projects. Then in addition to this, if you are having internships, that is going to be a best what do you say, that is going to be standing out in your resume. So minimum, I request you people to have a minimum of 1 year internship, 1 year internship experience with any CAE firm, and if possible, if you find any people, you can take them as mentors, any experts or any other people, you can take them as an mentors, and you can perform different projects. So here, in the process of learning a tool, and achieving an internship in any of the CAE firm, Internshala, whatever the course, I want to mention, like whatever the Ansys course that is present on Internshala, it itself will give you a very good starting point of how you can get started with the software, how can you get started with the theory and other stuff. And once I can assure you that once you go through the entire course and finish all the projects that are involved in that particular course, you will be able to attend internship interviews as well as direct CA engineer internships for the starting level. So I think this is it, Manpreet. This is how
Yeah.
we can become a CA engineer.
Thank you so much, Rakesh, for
Yeah.
that answer. And for all the keen learners here today, Internshala Trainings is offering a special 10% discount on the Ansys training. You can go on and use the code Practicals10. The link is in the description, and upon clicking on the link, you'll be able to see all the details, and you'll also be able to see the overview video of how the session is. So you can just go on and check it out there. And now I would request Rakesh to please take up some questions from our audience in the chat.
Yeah, thank you, Manpreet. So one thing I'm seeing is really the CAE softwares, they are not only for mechanical engineers, they can be utilized by a number of even electronics engineers. There are different modules for electronics people. There are different modules for civil engineering people. Mostly for civil engineering and mechanical engineering, mostly they will be using the same modules of ANSYS Mechanical for performing earthquake analysis, and suppose for example, if you want to perform any hydrostatic analysis, that also you can do hydrostatic analysis on different structures and other stuff using Ansys Workbench, you can do. Okay, I hope you got that particular answer. Yeah, as a fresher, if you are having knowledge of both Hypermesh as well as Ansys, that is going to be very good. And one more thing, guys, see, uh, opportunities, like one of the major problem that the industry is facing is we have lot of opportunities for CAE engineers, but lack of skilled people is the main problem. If you are having the right skill, you can become a CA engineer very easily, as well as you can earn handsome amounts of money. Suppose, for example, when compared with design engineers, you will be able to, especially in the starting, you will be able to earn more if you are able to get into this CAE, this one, like CAE. And another common question which I am seeing is, what are the specs needed for CAE softwares? Guys, if you are having any basic system with the i3 processor and 4 GB RAM, you can start learning about CAE softwares. But it is recommended you have like 8 GB system with some i5 processor. That itself that itself is enough for you. You can start learning about this CAE softwares, and even you can perform like entry level and basic projects, somewhat intermediate projects also you can do.
Sure, Rakesh. I think that would be all for today since we are short on time. Thank you so
Yep.
much for the amazing session. And thanks everyone for joining. Don't forget to like this video and share it with your friends, and do subscribe to our YouTube channel. You can also press the bell icon to get updates regarding our upcoming sessions, since we have a lot of interesting sessions planned out for you. And you can also join our Telegram community. The link is in the description. We also share all the updates there. So that would be all for today. Thank you so much, and we'll see you next time.
Yeah, thank you.
इसकी भी लग गई. कमाल है यार.
भाई, तेरी ग्रेजुएशन कंप्लीट होने वाली है और तू यहाँ बैठ के मटर छील रहा है. कोई ट्रेनिंग कर ले ताकि तेरी नौकरी लग जाए.
करने को तो कुछ भी कर लूं, पर उसके बाद नौकरी कौन देगा? शुरू कहाँ से करूं यार?
इंटर्नशाला ट्रेनिंग से डिजिटल मार्केटिंग, वेब डेवलपमेंट, डेटा साइंस, एनालिटिक्स और पाइथन जैसे बहुत सारे ट्रेनिंग्स हैं जिनसे हो सकती है जॉब पक्की। ट्रेनिंग सेलेक्ट कर और अपना करियर शुरू कर, और वो भी 100% प्लेसमेंट असिस्टेंस के साथ। इंटर्नशाला ट्रेनिंग्स।